So far what we know how to do is if we have an equation for a line that somebody hands us, we know how to find the slope of that line from the equation. Just read off the coefficient of x. It is m. M stands for slope. I don't know what language the m stands for slope. I think it's German or something like that. I don't know why we use m there, but it's historical reasons we do. And we also know, probably more importantly, how to discover, how to calculate the slope from knowledge of 2 points that are on a line. But there's, of course, more to the story, because we've talked about the m, the role that the m plays in this equation. What's the b? What does b stand for in the y equals mx plus b formulation? The intercept. The intercept with which axis? The y-axis, right. So that's another piece of information that we might know about a line, is we might know, or we might want to know, what is its y-intercept. So I'm going to make that a separate bit of information over here. And that y-intercept is exactly the b in our y equals mx plus b equation. Y-intercept. And the y-intercept, again, as he said, is a place on the y-axis where the graph intersects the y-axis. So, for example, if I just sketch over here another graph. So here it is, x-axis, y-axis. Let's suppose for the moment that all of my tick marks here are marking off by 1s. So this is 1, 2, 3. This is 1, 2, 3. I'm going to sketch in a line. Let's say my line looks like, I don't know, this. So there's my line, this red line. How would I discover from this graph, assuming that it passes through the points that it looks like it passes through, and we'll talk more about that in a minute, how would I find what the y-axis intercept, y-intercept is of this graph? Where is the y-intercept of this graph?
Where it hits the line.
It's where it hits which line?
Y.
The y-axis, right. So we're always going to find the y-intercept on the y-axis. So in this picture, that's right here. And so if I want to know what the y, I should just find the coordinates of this point. Well, which coordinate of this point do I automatically know without having to do any counting or anything? All right, so you did the counting for me and found -3. And is -3 the x-coordinate or the y-coordinate of that point? It's the y-coordinate. -3 is the y-coordinate of that point. What's the x-coordinate of that point? How far to the left of the origin or to the right of the origin is this point?
0.
Exactly, 0. So that's actually super meaningful as well. Because regardless of what equation that we graph, this goes whether this graph is a line or whether this graph in your next semester course is a parabola or a hyperbola or an exponential function or a logarithm function or anything, whatever kind of thing that we're graphing, the y-intercept is going to be a place where the x-coordinate is 0. So that is a constant. No matter where we see other y-intercepts in mathematics, we'll always have the connotation of being the point on this graph where x is equal to 0. So that's always the case. And then the y-coordinate is what tells us the value of b in y equals mx plus b. So if I give you an equation of the form y equals mx plus b, and you need to find the y-intercept, all we have to do is just read off the constant term. Right? It's the term that doesn't have the x attached to it in y equals mx plus b. And so the good news is that why y equals mx plus b is so useful is it tells us, it's often the end goal, maybe I'll put it that way, it's often the end game for finding an equation for a line if I know the slope and if I know the y-intercept. If I know those two things, then I can go directly to my answer by plugging the slope into m and the y-intercept into b. And that's often the end game in these problems. The slope is m, and the intercept is b, the y-intercept is b. So there are a lot of questions in this module that are going to ask you, find an equation for blah, 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 blah. It's going to describe a line that you have to find an equation for. And so we need to end up in this box down here at the bottom at the end of the problem. How do we get there? Well, figure out what belongs here, figure out what belongs there, and then just put those two players into their places. Find the slope, find the y-intercept, and then just stuff them into the mx plus b template, and you're done. It's the work that goes into finding the slope and the work that goes into finding the y-intercept that sometimes requires some elbow grease. Right? And that depends on what kind of information we have. If the information we have tells us 2 points, then we're going to have to do some work, this kind of work, to determine the slope. But then once we do that, we may or may not already know the y-intercept. If we already know the y-intercept, then we can go straight here. But often we don't. So the last problem type that I want to put up here is, how do we find the y-intercept when we start only with 2 points? I want to go back to the example that we did before. So I'm going to clear off the line I drew on this graph and go back to, we had 4, -4 was one of our points. 4, -4. And our other point was 1, 5. 1, 5. And so we had a line that looked like this. Let me try doing this as accurately as I can. Good enough. So there was our line. It went through the points 1, 5, and 4, -4. And so up until the point where we saw this line last, we determined that the slope of this line was, what was the slope that we found? A minute ago. So we determined the slope of this line was -3. And again, the reminder of how we did that is we measured the horizontal difference between the 2 points that we knew and found that the horizontal distance was +3. As I go from the leftmost point to the rightmost point, I go to the right 3 units. And then we measured the vertical distance to be -9, so we went to the right and we also went down. The right 3 units and then down 9 units. And then we divided the latter by the former to get that -3. So -9 divided by +3 is how we got the number -3. So that's how we found the slope. But the slope by itself doesn't give us a full equation for this line. It only gives us the m part. We don't know the b part. So how do we find it? How do I find the y-intercept of this line?
Zero,
0, 3.
three.
So 0, 3 would be right here.
No, wait. You're on the red line.
Uh-huh. Okay, so one thing we could do, if we have a graph, we can just do what we did with the previous line and find that point on the graph where the graph intersects the y-axis and make an educated guess, right? That it would look like the coordinates of that point. Well, we know the x-coordinate is going to be 0. For the y-coordinate, we would count up 6, 7, and guess that maybe the y-coordinate is 8. That's great if we can believe our eyes. But I see a lot of students on the exam in this class try to believe their eyes and guess wrong. And the reason is, graphs are great for overall behavior and overall trends, but graphs aren't very precise. We can't tell from this graph whether or not that line crosses at y = 8, or maybe it crosses at 7.9. Maybe it crosses at 7.865. Maybe it crosses at 1.5 times, no, it would be 2.5 times pi, or something like that, right? We don't know where this line crosses exactly. We can say it's probably close to 8, but the graph is never going to be exact enough to give us the assurance that that y-intercept is actually 8. And approximation doesn't fly in algebra, or in pre-calculus, and even in most calculus classes. We want to be exact. We need to know exactly where that line crosses the x-axis. And anytime we have a need for exactness and precision, graphical tools are never enough. We need an algebra tool in order to do this. So we need a way of using algebra to determine, on this line, when the x-coordinate is 0, what is the y-coordinate? So we need to do that using the information that we have at our disposal. So what do we know about this line? We know its slope is -3. And we know the coordinates of 2 points on this line. So what we can do is the following. I'm going to do the scratch work up here in the upper right because that's going to be what our sort of where I'm going to recommend that we go with this. Is if I know the slope and I know a point, we can determine the y-intercept using the following calculation. So we know that the equation of our line is going to fit the y equals mx plus b template. And we already happen to know what the slope is. So we're going to put the slope in as our m. So our slope is -3. That means I'm just going to put -3 in here next to my x. So this is what I know the equation is going to look like so far, but I just don't know what b is. But my equation now has 3 unknowns in it, an x, a y, and a b. So it looks like I've taken a step back. If I want to find a value for b, I need to give this equation values for x and y. Where am I going to get values for x and y that I can plug into this equation to let me determine b? How about right here? How about from either of the 2 points that we know are already on this line? Because every point on this line has to satisfy y equals mx plus b. That means that same relationship that knits my first y coordinate with my first x coordinate must be the same as the relationship that knits my second y coordinate with my second x coordinate. And the upshot of all of that is that we can plug in either of our 2 known points. Plug in any known point into this template, and that will give me an equation that only has b left as an unknown, and I can solve that equation for b. That will determine my y-intercept for me. So in our example, we have 2 different points to choose from, 1, 5, and 4, -4. Let's choose 1, 5. I think, like you, like to choose the ones where we don't have any negatives to carry around. So if I replace y by 5 and x by 1, and then I put the rest of this equation back in place, I'll have a -3 in front of my 1 as a coefficient. And now I have an equation that I can simplify and solve for b. -3 times 1 will give me a -3. And from here, how do I get b by itself? I just have to add 3 to both sides. That's going to give me b by itself on the right-hand side, and what do I get on the left? Oh, lo and behold, that's the 8 that we thought the graph was telling us, and it turns out that indeed the graph, so our speculation based on the graph was correct. Right? So that's the skill that, for whatever reason, I feel like this is the skill that people forget, or they skip, or they're so happy that they discovered what the slope was that they forget that there's this second part to do, to find the intercept. So that if my job in this problem was to discover an equation for the red line, which was graphed over there, now I have all the information that I would need. I have the slope, -3, and based on this work, I also have my intercept, 8. So, according to all of that, what would an equation for this line be? So we have to finish our thought here. If I wanted an equation for this line, what would it be? I have my slope. I have my intercept.
Y equals -3 plus 8.
Plus 8, right. I just have to put the players into their places. Put the slope in where we see the m, put the intercept in where we see the b. Y equals -3x plus 8 would be an equation for this line. And as usual, there are ways of checking to see that your answer is correct. All we have to do to check is try plugging our original points back into this equation and see if it balances. If I plug a 5 in for y and a 1 in for x, I should get both sides of that equation to be the same. They should both equal 5. If I plug a negative 4 in for y and a 4 in for x, I should also get that equation to balance at negative 4 on both sides. So you can check your work. You should check your work, because I want you to be the one to catch any errors, not me. So when I catch them, you lose points. When you catch them, you don't. As long as you can go back and troubleshoot your work.